My name is Hugh Hayden. I'm a senior director at Niantic Spatial, and I lead the go-to-market. My goal of the session today is to share a little bit more about spatial technology that we've developed over the years and how we're applying that in the real world today to drive real-world business impact. This is intended to be an introduction, an overview. We do have a large presence over by the front entrance, so should you like to go a little bit deeper, I highly encourage you to go check out our booths, check out our demos. There's 10 plus demos that we're running over there, and we have a large team that's ready to go deeper on the technology, and we can certainly go deeper on discussing the applications of this technology. Niantic Spatial is building the 3D maps of the future. The maps of the future are readable by humans, but they're also readable by machines. They allow us to visualize the world in new ways. They allow us to localize our devices, whether that be a mobile phone, a headset, a robot, or otherwise. This is the foundational layer of geospatial data that we are building, that we are putting together, and we're putting to use. We're building these 3D maps, we're building the spatial intelligence with the data that we're capturing through spatial capture, which we'll touch on a little bit more in a few moments. We're processing millions of scans every month, whether those be public or private. And we're training networks, we're training parameters, over 50 million networks trained and over 150 million network parameters trained. This is what allows us to build these 3D maps, but this is also what allows us to visualize those maps. And specific to the networks trained and the parameters, this is what helps us to build location intelligence. So you can understand where you are in the world, you can understand what you're looking at, you can understand how that thing interacts or is in a relationship with the things around it. And so as we think about spatial computing and what the building blocks of spatial computing look like, the technology that Niantic Spatial has developed and is applying today is the intersection of that location data, extended reality technology, in our context, typically augmented reality, or in some cases, some experiments with mixed reality, and finally, artificial intelligence. And when we think about the Niantic Spatial platform, and we think about the building blocks of spatial computing, we think about the three categories of services that we provide. These are spatial capture, locate, and augment. We'll take a look at each one. Starting with spatial capture. Typically, we use the term scanning to describe this set of services. There's several paths with Niantic Spatial as it relates to spatial capture. The first path may be Scaniverse, which is an app available today on iOS or Android. This is a mobile-based scanning application for typically smaller areas. We think about 10 meters by 10 meters generally. A good example is a statue or a small room or whatever the case might be. Another path for scanning with Niantic Spatial or spatial capture is what we refer to as Photon. This is proprietary scanning hardware. This is what we use for scanning and capturing larger areas. So imagine the facade of an entire building, a city block. What you see in the GIF in the top right is actually the exterior of the San Francisco Ferry Building. That was scanned with Photon in about 25 minutes, just to give a point of reference. We're also experimenting with drone imagery and satellite imagery and understanding how that can enhance our ability to capture data, but also to fuse that data to push these maps forward. The outputs of the scanning flow is Gaussian splats, which is generally used for visualization or machine learning, or 3D meshes and 3D maps, which is what we use to turn on computer vision. That allows us to localize, which is the next category of services, which is locate. And we think about the location stack as being powered by any location input that you might have available or the user might have available to them at that moment in time. For us, primarily, the focus is on localization through computer vision. Our localization algorithm is referred to as a visual positioning system, or VPS. And what VPS is doing is essentially perceiving what a person is looking at through their device, their camera. It's matching what they're perceiving with the map that has been captured previously, And boom, once you have a good match on that query, you have localization there. And you're able to localize that device with regard to position, where that device is in the world, and pose, how that device is perceiving, the statue or the building facade or whatever the environment may be. This is also how we get to centimeter level precision in terms of where and how we place digital assets. That could be a Pokemon character, that could be a digital overlay in a warehouse, or that could just be verifying your location down to the centimeter to understand exactly where you are, to remove any doubt. And because we are localizing with computer vision, we're able to localize in GPS challenged or even GPS denied environments. And so if you are, for instance, in a warehouse and you have a couple tons of steel and concrete above your head and your GPS is getting a little wonky, we can still localize that device and help you understand, again, where you are, what you're looking at, and how you relate to the rest of the environment. And then finally, the third category of services that we provide is augment. I think this is the most intuitive of the categories, so won't drain this one. This is generally how we refer to our computer vision stack. So this is the occlusion, this is the physics, this is what allows us to deliver that digital content. But importantly, this is also the semantic understanding of the environment. In our game Peridot, for instance, there's a demo out at our booth. The Peridot character understands if it is running along asphalt or grass, if it's running up to a bush or a tree, because we have 25 categories of semantic understanding in the Peridot game today. In our research and development team, we have 200 categories of semantic understanding. And so we're building these models with the data that we're capturing on an ongoing basis to turn on these types of use cases. To pull it all together, this is the GIF that you saw on a previous slide. This is the capture of the San Francisco Ferry Building. On the right, you see a GIF of a really lightweight tourism activation. This is a very lightweight wayfinding experience, in which now we're using the 3D map that was built from spatial capture step. We're localizing against the facade of the San Francisco Ferry Building. And just as a point of reference, maybe you're about 100 meters, 50 to 100 meters removed from the ferry building, so you can get a sense of how that VPS is localizing against the building there. And then finally, we're using that computer vision to orient and overlay these the digital assets to give a sense of where your next point of interest might be. When you're looking in the building, where's the bakery? Where am I going to get a cup of coffee? How do I get to my ticket? And one of our core beliefs is that this technology, the three categories of services I just talked through, are extremely versatile. And this makes them extensible across many industry verticals and use cases that cut across those industry verticals. And so as we are working with our customers, when we're working with our partners, we're seeing traction in 3 specific areas. And again, we'll talk through each one of these. The first is around warehousing and logistics. The second is around spatial planning and collaboration. And the third is around immersive entertainment and experiences. When we are applying this spatial technology and we are working with our customers and partners, we're laser focused on driving real world outcomes. We're moving to a place where this technology needs to be more than novel. It needs to be more than fun. It needs to be driving top line or bottom line impact. So a good example of this is warehousing and logistics. When we talk about this particular set of use cases, we're thinking about verifying that location for a person that is picking up a parcel or dropping off a parcel in a place where GPS isn't working real well, or it's a challenging delivery. We're thinking about being able to lay out and visualize the warehouse and track elements of the supply chain on a innovative basis or in innovative ways. And by doing this, reducing operational costs from things like lost packages, or reducing operational costs by improving delivery time for problematic deliveries. There's a demo that is running at our booth, and I encourage you all to check it out, that sort of takes you through this flow. We have a mock-up of a front door. You can localize with VPS, and you can get a sense of how this works. Booz Allen Hamilton also built a prototype and is developing a warehousing solution using the visual positioning system, as well as other location inputs, which has been exciting to see develop. The second example, or the second area in which we're finding traction and driving business outcomes is spatial planning and remote collaboration. And so here we're thinking about going to a location, doing a site survey, building that digital twin or that 3D model on your device very, very quickly so you can visualize that. You can come back to that in the future. But by nature of having done that spatial capture as part of the site survey, now you're able to localize there. You're able to put a digital overlay there, and you're able to understand what the steps are for setup, or how to guide people in, or what the specific actions are needed there. We're also thinking about remote collaboration. And again, there's a partner at our booth called Sphere. Their team is out there running live demos today, in which they have incorporated our scanning technology and our localization technology, VPS, into their solution to enhance, differentiate, and improve their remote collaboration and remote assistance solution and software. And then finally, the third category is really kind of very near and dear to our heart. This reflects a lot of Niantic's legacy. This is immersive entertainment and experiences. And so on one hand, there are immersive experiences like games and scavenger hunts. And I was fortunate enough to be part of launching a number of games and growing Pokemon Go over the years. We love games, absolutely love it. Where we're moving is finding additional applications of this technology in places like training. So another example out at the booth, we're working with a partner called Alias to enable training experiences using VPS so that we're able to improve productivity, improve engagement, and enable those training experiences. We're also working in travel and tourism. And to get into the next example, I'll invite Gregory, Vice President of Americas from the Singapore Tourism Board, to discuss a little bit more about how they're using Niantic Spatial technology to create the Garden of Wonder in Singapore. So please welcome Gregory on stage.
Hi, everyone. Very nice to be here and to partner Niantic to share the stage. I think before we kind of speak a little bit further, we've prepared a little preview of the pilot experience that we developed together with Niantic. So please have a watch.
All right, Gregory, thank you so much first for your partnership and all of the amazing work and really inspirational work that you all are doing. We value the partnership, and we're so excited to see what's coming together. I would love if you could start us off with just a quick introduction of yourself, but also introduction of the work that you're doing.
Sure. So as Hugh kind of introduced me, I'm Gregory. I am the VP Americas for the Singapore Tourism Board. And the Singapore Tourism Board, we're an economic agency tasked to really champion tourism and make it, an economic driver for the country of Singapore. And I think the fun part about my role here is that we champion innovation as well and the future of tourism under this initiative that we have, or work stream, like we like to call it, called Future Tourism, where we kind of pilot and work with different partners to kind of test tourism use cases for different types of emerging technologies, including AR. Yeah.
And the video that we just saw is just a quick demo video of Garden of Wonder. Would you share a little bit about what drove you to embark on Garden of Wonder?
Yeah. I would say that STB, we're very deeply committed and really see the potential of AR. And we've actually launched a couple of AR initiatives and projects since 2021. I think for us, we see it in three different ways, right? One, Singapore, if you're not very familiar, we're quite a compact, small city. So we see AR as being able to allow us to layer on new experiences over the same attraction and create and enhance the entire visitor experience for our tourists and locals alike. And the second one is really enhancing the visitor experience, right? You can interact with an attraction or a venue in one way, but with the power of AR, you really transform the dimensions in how one experiences it. And thirdly, I would say is trying to also create new types of revenue streams, I guess, for our tourism businesses and stakeholders out there.
Yeah, I think that's what we've seen you all build is a really good example of how we think about delivering the spatial service as well, and kind of gets back to that concept of driving that top line and bottom line impact. Would love for you to share a little bit more about your experience with Niantic Spatial and the Niantic Spatial tech stack.
So it's been a great kind of partnership with Niantic so far. We're very excited. I think for us, when deciding to partner Niantic, a few things stood out for us. One, obviously, is Niantic Spatial's visual positioning system, or VPS. It really provided us that centimeter scale accuracy that allowed us to really position and place AR experiences at different points of interest within the flower dome of the Gardens by the Bay. So that was really important for us to provide that kind of accuracy when users were interacting with the experience. And I think secondly was really the synchronized gameplay. I think Hugh touched a little bit about it just earlier. And I think that got us quite excited. Just because for us, in terms of an experience, we really want it to be a shared experience. And the ability to create those experiences with this option allowed us to then make it into a multiplayer interactive experience. So if you saw the video earlier, there is this screen where there is these two people that they are trying to shake the olive tree and collect as much olives as they can to turn it into olive oil. So that's just one of the kind of unique things that we were playing with in this shared AR experience. And I think thirdly was really Niantic's kind of integration with different headset devices. I think in our different experimentations with AR, we've done it on mobile devices, but it also has it has the ideas of convenience, but also has limitations. So the integration really allowed us to, I guess, break away from the fatigue of using a mobile phone and allow the user to really be immersed in the experience with their hands and gestures as well. Yeah.
Very cool. That's great to hear. Something that we think about a lot with regard to the visual positioning system and that centimeter level accuracy, I think there's the kind of the quantitative element there, but then there's this qualitative element which really nods to the digital craftsmanship that's really necessary to build these really compelling, really fun, really valuable experiences that are at the level of quality that they need to be as part of something that is as special as these locations. And then the second piece of the visual positioning system that really comes through in the experience is exactly that shared element that you alluded to there or pointed to directly. And part of the magic of VPS is when multiple users localize using VPS, boom, they're in a shared experience. They're in that shared moment. And this is a way that Niantic Spatial has really faded the technology to the background so that it's a much more intuitive, much more immersive, much more of a natural experience. So love hearing all of this. Really interested to hear what's next.
Yeah. So what's next is really actually launching the pilot experience. So it's actually today's kind of where we first announced it. The pilot experience will be launching in a couple of weeks in Singapore. It'll be a closed door pilot, and I think we really want to take this chance to gain kind of operational, business, and consumer insights to understand how we can really scale this into a commercially viable model, right? Which I think is a lot of questions that we have on people's minds today about AR experiences. So that I think is the immediate kind of next steps for us. I think secondly, we're very excited. I think I was at the keynote this morning, and a lot of the speakers were talking about the convergence of AI and XR and AR. We're equally excited, particularly in the way that I guess it will help us to reduce the developmental cost of creating these AR experiences. I think that will really be a game changer for us. And then thirdly, I would say is the new headsets and devices that are coming out. I think, we tried with the Magic Leap over here, but I think there's so many devices and they are being produced in, different successions, all lighter, longer battery life. And I think for a consumer experience in a very crowded attraction, all these are very important considerations. So we will definitely, be excited to see how we can test with some of these as well. Yeah.
Very cool. Very exciting. Again, thank you for your time today and joining me up on stage for this conversation. And thank you so much for your partnership. We're excited about what comes next.
Yeah. Thank you for giving us the space. Yeah.
Very cool. And thank you again to everyone that was able to make the trip and join us this afternoon. We have about 5 minutes left in our time, so we're right on track, I think. Looking at the moderator, yep, we're all right on track. So,
anyone has a question, please come to the mic.
Yep, welcome your questions.
I have a technical question on VPS. What's the percentage of change before you lose on the current set, on the current scan environment? What's the percentage of change before you lose the accuracy?
I'll do my best to answer your question, and if it's not going quite deep enough, again, encourage you to, one, find me after, and two, make your way over to the booth, and we'll get you hooked up with one of our eng leads. But the concept of the visual positioning system is that, again, you're basically querying what the device is seeing versus the map that has been created in the past. And so the closer that the closer the map is to what you're perceiving, the better the localization will be. And so it's hard to give you a specific, percentage type answer to your question. But what we generally find is we generally are seeing a number of considerations. The first is that as more scans are built up over time, or more scans are captured over time, different lighting conditions, different weather conditions, different eventualities or stages of construction, for instance, that 3D mesh and 3D map is improved over time, so that localization improves as well. And so when we talk about having 1.5 million VPS locations activated, that's our way of saying that we have enough data in those locations to give you a really good localization, reliability score in different environments, whether it be lighting, or whether maybe there's snow on the ground, or there was scaffolding up one day and now there's scaffolding not up the other. And so that's how we are able to build robust locations with regard to VPS activation. The other consideration is that we're building technology today, or a set of technology today that's enhancing our VPS service. And you'll hear Brian McClendon talk a little bit more about it in the future, and you'll hear a lot of folks over at the booth talk about it as well. This is the large geospatial model, or the LGM. And what the LGM does is it's an inference model. And so if you are looking at an incomplete 3D map of the particular location in which you're trying to localize, the LGM for localization will infer what that map would look like if it was complete and improve your localization reliability in those instances. And so this is an example of the service that exists today and the technology that's coming behind it, which is blending the location intelligence, that XR technology, and AI for inference to improve VPS and enhance that service. Great question. Yeah, please come find me afterwards if you'd like to go a little bit further.
Hi, my name is Ash. I used to be a civil engineer, worked in the construction industry. I've been doing AI work the last year or 2 years. But I kind of love to hear both your thoughts on what exactly does it take to actually get enterprise adoption? Because I've been to so many of these conferences, AI, XR, and it's all nice, and I love the technology. But the reality is, it's so difficult to get traditional industries like construction, manufacturing, logistics to actually implement it outside of a couple one-off use cases and projects. So what are you guys thinking about, maybe as like, a city or as a private company? How are you guys thinking about partnering up or doing things to change traditional industries?
I'll take that first. So as I mentioned, for us, we're the Singapore Tourism Board, right? So all the attractions and hotels are basically our stakeholders in Singapore. And I think you're really right. That is still the question that we're trying to crack. And I guess that's why, as STB, we've kind of decided to take the leap. Because I think for a lot of XR experiences, there's a lot of like a leap of faith, a lot of investment that goes into developing them. So interestingly enough, for example, STB, we have our own in-house development team. So particularly for Garden of Wonder, this project, it was kind of, we worked with our attraction, which is Gardens by the Bay. They provided the venue, they collaborated with us, and we stood up our development team, on of course, together with Niantic support and collaboration. And I think it was very important for us that when we set out on this project, we kind of, established some clear objectives of what we wanted to test, right? So that we can, deliver more credible and reliable data to give back to our stakeholders to say, it's an emerging technology, but it is moving at a pace. But these are, they are very, promising results, from the users, from a development standpoint, as well as, from a venue standpoint, so that I guess we can then present this to other kind of stakeholders to say, hey, this is something that you should really consider moving forward. But I would say it's still a journey. That's why I said we've started with several AR initiatives, and I think since 2021, every initiative and every project that we've done is a bit different, and we, learn from our past project and apply it to the next one as well. Yeah.
And we have about 20 seconds left, so why don't we get to the next question? And I'm happy to share my thoughts on that question following.
I'll be real quick. I'm just very curious how you create the semantic bridge between AI and kind of a spatial awareness. How you keep that accurate, how you keep how it knows, and how you can correctly map it to the reality.
Yeah, great question. I don't know if the 20 seconds is enough to answer that one, but I'll tell you that we're collecting data. Our customers, our partners are collecting data. We're training our models based on that. And so we're able to train the computer vision to localize. We're able to train the semantic understanding models to understand one's environment. That, I believe, takes us to time.
That's it. That's all the time we have for the questions. Thank you. Let's give them another huge round of applause.
Thank you.
Thank you, everyone.